Do y'all want to have electricity at your house? You need to listen to these guys. So this panel is going to be about the Texas grid, which has, of course, been on everybody's mind, especially here in Houston lately. A lot of important issues. We have a really interesting panel today. We have Elaine Ball. She's the Chief Strategy with CPS Energy. This is I guess it would be fair to describe it as the San Antonio utility, plus a bunch of other stuff. One thing, you're a partner in the South Texas nuclear plant, which is obviously an important issue. We have Michael Skelly, who's the founder and CEO of Grid United. His company mostly specializes in building long line transmission, but Mike's been around this business for a long time, wind and all sorts of things he can talk to us about. And then we have Jesus Soto, who is the COO of CenterPoint Energy. And I just want to let you know, he came after all the problems, so don't be yelling at him about your electricity going out. And so guys, I want to start the conversation. I want to start by talking about the generation part. You know, there's really three parts to this puzzle. You got generation, you got transmission, then you got distribution. And all three of these are very, can fail at very different times. So the Winter Storm Uri was primarily a generation failure. That was really the problem that we had there. Some of the other ones have been more distribution, derecho, and the hurricanes that come through tend to be the local distribution lines, which is what Jesus is going to be telling us about. But let's start with I want to start by asking you, Elaine, about the fuel mix in Texas right now. Can you kind of describe what are the sources that we're getting our electricity from today, and how's that changed over the last 10 years?
That's a really great question, and I'll start with what's happening actually right now. I just pulled out my ERCOT app before I walked up, and right now.
You're a true nerd.
I'm a super nerd. Yeah, thank you. Okay, I'm a chemical engineer, and I'm like the deepest energy nerd, so I'm the worst person to take to a party. But right now in ERCOT, we're paying about $30 a megawatt. It looked like about 20% solar, about 10% wind. We have our tried and true, about 9% nuclear cranking out, and we had about 10% coal and about the balance, natural gas. And so in the morning, that's what it looks like as we ride through the day. We can get to parts of the day where it's all solar, all wind, and all nuclear virtually. And so that's kind of where we're at right now. The state does have 4 nuclear reactors. We have quite a significant amount of natural gas, and then burgeoning solar, wind, and storage. And right now, if you look in the ERCOT queue, the number 1 and number 2 resources for interconnection, like additions, are solar and storage. And so we're now starting to see more gas getting built with all the large load coming. But we've really transitioned over the last 10 years, really due to the advent of fracking and the reduction in natural gas costs, as well as expansion of solar and wind, to see more of those resources come into the grid. As we see more large load, we are seeing a lot more interest in building natural gas, so we do think that's going to change. And small modular nuclear reactors are really becoming a thing. They're actually coming to market, and we're seeing quite a bit of growth in design in that space.
So let me talk to you about just about solar and batteries, because I see those as kind of being connected. It seems like that's the one I hear the most about, and when I'm seeing capacity added these days, it seems like the one that's being added the fastest. Is that right, or?
It is, and some of it is speed to market, but some of it is just quite outright just cost, right? They're just lower cost resources, and depending on where you're interconnecting. You know, the phenomena we're seeing now is we have tens of thousands of megawatts of solar that produces reliably every day. Everybody talks about how unreliable solar is. It's pretty dang reliable. We know how the planet turns, but it's intermittent, right? And so as the sun sets, we'll see tens of thousands of megawatts come off the grid in a matter of minutes. And that's where storage really, really helps us. We'll see those tens of gigawatts of batteries kick in, and they've been charging all day. They kick in, they smooth out while we're still, heating our homes or cooling our homes and businesses, and they really smooth out that rapid ramp out of solar, keep prices low, and keep the grid reliable. But storage is really only, designs right now are really only commercially realistic for about 4 hours, and that long duration energy storage still hasn't come to bear.
So it's really just to get you the evening transition primarily. Is that
That's
right?
Right. Mm-hmm.
You know, Hazel, you and I were talking about, in terms of relying on storage in emergency events, probably not going to be that helpful. Is that right?
Well, you know, every event is different, Bill. You know, what you and I were talking specifically about was, for example, most recent winter storm. We were monitoring just the availability of power for that morning load, and a topic of conversation was how much battery is going to come into the market in that morning. You know, battery resources have a choice in terms of if and when they charge, and if they're not charged, they're not then available to contribute into the market. So that's kind of a nuance when it comes to that resource is, you know, we monitor when they're charging, because that's obviously a demand of the grid, and their availability of being charged to contribute during a need, such as a morning peak or an evening.
And as I understood what your point was, is my microphone working? Can y'all hear me okay? What's going on here? There we go. Is that better? So I think what you were saying is that if you're in an emergency event, the power prices are going to be high, and so if you're operating a battery storage facility, it makes no economic sense to recharge in that situation.
It's a market condition, right, Bill, that in terms of what's happening, you know, day or days before of that event as to when those storage systems decide to charge.
Okay. So really, we need to think about battery as that evening transition. Is that really a fair description, I think? Let's talk about nuclear for a second, which you brought up.
Bill,
Yeah.
just on the battery point,
Yeah.
the evening hours are very important, particularly as we use more and more solar. So if you can see this in the market over the last couple of years, in 2023, when we didn't have nearly as many batteries, we had a few days where it was kind of touch and go in late evening. Since then, as Lane pointed out, we've built, I don't know, close to 20 gigawatts, and that's an investment of, think about that as around $6 billion of private investment that's gone into batteries. And now we don't really have that late afternoon issue. So you're not going to get, here's the good news, folks, you're very unlikely to get warnings from ERCOT this summer or in probably any future summer saying, hey, turn down the AC. Now, there may be good reasons to turn down the AC, but you're not going to get a warning because the batteries are going to be kicking in and keeping things going in the hottest days of the year.
Yeah, and that's primarily because it's primarily because we continue to run our air conditioners on into the evening pretty hard, and so that's what picks up when the solar lets off, right? Am I getting that right?
Yes, and we have a big state, and West Texas, like it can be getting dark in Houston, and West Texas Solar is still cranking out some power.
Yeah. Let's talk about nuclear for a second. You know, I've always thought we made a huge mistake in just completely taking nuclear out of the equation here, 30 years ago or something like that. The small modulars are out there, and I guess Dow's thinking about building some down at their facility. What is the realistic timeline on that? I'd kind of like all three of you comment about that, but Lane, why don't you start?
Yeah, I agree with your sentiments on our move away from nuclear. But yes, there's a number of projects that are throughout the United States. Here in Texas, Dow is partnered with a company called Axe Energy, and they're going to be using that not only for power but for industrial heat. And obviously chemical processing. You know, we've been long-term owners. I've served on the board of the South Texas Nuclear Project since the 80s. And nuclear is such an important part of the future of our entire industry. As we see more data center growth, more large load growth, and we talk about, you know, management of resources, both power and water, nuclear is going to be part of the mix. And you see a lot of the hyperscalers striking nuclear deals and investing in new technology. Look, small modular nuclear reactors get a lot of questions of when are they going to come to market. I'm a nerd, but I'm also pretty boots on the ground from West Texas. We've had a fleet of small modular nuclear reactors operating for a very long time as a society. It's called the Navy Nuclear Fleet. And so there are SMRs floating out in the ocean. So we have lots of commercial experience with them. It's really been about market, right? Making sure that the market can support the investment in those technologies. There are, over 5 dozen designs out there. There needs to be some rationalization of those designs, but we are seeing a tremendous amount of interest. We're under an MOU with our military joint base partners for exploration of actual deployment of small modular nuclear for resiliency purposes. So we see, as the cost curve comes down, the space of small modular to be a real commercial reality. We're probably thinking mid-2030s is when we're going to start seeing more in the dozens to more of those designs. But we do believe, I mean, you see announcements in Canada and here in the U.S., we will start seeing new nuclear toward the latter part of this decade or early 2030s.
Mike, you got some thoughts on that? You look like you're...
So, yeah, so I recently had the opportunity to visit Vogtle, which is a new nuclear plant in Georgia. Just an amazing project, particularly if you're a projects nerd like me. They're very expensive. Nukes have the promise of nuclear power for the last 60 plus years has been, it's going to be too cheap to meter, and we're going to, it'll be abundant and cheap and so on. We haven't figured that out. And in Europe, they're trying to build nukes. They're coming in. They're very expensive. China has gotten some of the costs down. There's some discussion about, like, would we want that standard of design and so on. So it feels like we can get to big nukes to the $10,000, maybe. Like the most recent ones have been like $20,000 a kilowatt, and maybe we get to 10,000 on big nukes. But the jury's still out, and so it's not. I think we should keep trying to figure it out, but so far I'm not hugely optimistic. And then small nukes, small modular nukes, Dick Weekly and I were talking about this, and we have a joke in our business, and apparently his, big projects, big problems, little projects, big problems. So making things smaller doesn't necessarily solve your problems.
Yeah. Jesus, what are y'all thinking about
Yeah,
that?
I mean, we my view is consistent with the fact that large nuclear plants like Vogtle, very expensive and lots of time, right? The appetite for those types of projects is lower than the focus and energy that we're seeing on small nuclear reactors. You go to any EEI event and you'll find several parties that are there that are focused. There's a lot of investment, a lot of technical focus going in. It's not recreating it from scratch, given the experience that we have with like Navy fleets. But from our vantage point, the technical and financial focus right now is very much concentrated on small nuclear versus the dialogue on large nuclear facilities like Vogtle.
It seems like the regulatory permitting part, so if we could figure out a design and say this is the design we're going to use so it could be replicated, almost like an assembly line, would be a big part of trying to get the cost down.
Yeah, that's exactly the focus of the small modular designs that are out in the market, and relative to permitting and licensing. The federal administration has taken several steps to create new paths to have these new designs go critical, actually, by as early as next year in conjunction with the national labs. And so, I do think there's a recognition that there has to be regulatory reform. Many of these new designs, they just are intrinsically different than the light water reactors. They do not have the scale. They have walk-away safe provisions. They're not huge consumptive water users, and their technical designs are just fundamentally different. The physics is the same, but the chemistries that are being brought to bear is markedly different. And so, I'm optimistic, again, probably in that next decade that we're going to see rationalization, and that first SMR, is going to be extremely costly. We know that, but as we get to nth of a kind, the intent and there's actually several Texas-based SMR developers that are concurrently designing their manufacturing facilities with their reactor design to do exactly what you're saying, Bill.
Yeah, Mike?
Yeah, so the most interesting comparison that I heard on small modular nukes is that of the development of large commercial airliners. And a large commercial airliner takes, decade plus to develop. The development costs are in the many billions of dollars. And then you got to sell, 100 plus before it starts to make your money back. So, and we don't have that many. We got Airbus, we got Boeing. That's kind of the game. So maybe there's less, and I don't know what they are because I'm not an expert, but here it's a large capital good. It's the requirements around safety are, just it has to be flawless. So maybe there's lessons to be learned from the aircraft world in terms of how one thinks about this and how one develops the systems and so on that are applicable. I don't know.
I think we'll shake out to just maybe one or two or three manufacturers.
Yeah, I think most observers agree that we might be better off. Like, it's hard to figure out, like, how do you down select the 20 small modular nuke developers or technology developers now when they've all got, great ideas? How do you down select that to a few national champions, if you will?
Before we leave the generation issue for a second, I'd like all three of y'all to comment on, we're seeing this, for many years, the per capita consumption of electricity been going down because we were getting a lot more efficient. But all of a sudden now we're electrifying everything. We're electrifying cars. We've got these AI gigantic data centers being sent. We've got the LNG, which you use. How confident are the three of y'all that we're going to be able to build enough generation in Texas to deal with this onslaught of demand that's coming?
We were all deeply in thought. That wasn't a pregnant pause.
Nobody wanted to answer the question. You noticed that? It's a bad sign.
No. So, absolutely. I'll just speak. I know I'm here amongst Houston friends, but I'll speak about what's going on in Central Texas. So San Antonio, we're CPS Energy is the company that I work at, and we have a peak of about 6,000 megawatts. And I manage our large load interconnection, and so right now, and we've been in business 160 years, right? So 6,000. Right now, we have an interconnection.
So let me just interject. She manages large load interconnection. In other words, if you're a data center, you got to go through her. She is a very popular person.
My phone's, everybody has my phone number right now. But so just for scale purposes, right now we just briefed our city council. We have 26,000 megawatts of interconnection in queue right now. So think about that, right? For scale, our South Texas nuclear project, 2 of the 4 reactors in the state, 2,700 megawatts. So 10 times the output of the nuclear project near here is what I have in queue. So huge amounts of interest. I think there is a tremendous amount of capital and drive to build generation. As I mentioned, solar and storage, pretty quick, a lot of it. These large loads have different characteristics. They come on, they have a lot of consumption around the clock. They also have a lot of movement. They move around, they create a lot of transients. So the nature of the generation that we need to serve this type of customer from a physics perspective and from an economic perspective are fundamentally different. So we are going to continue to need to have mid-merit baseload type generation. Think about gas plants, eventually maybe long duration energy storage, but right now we can't build things fast enough. I'll just be candid. The supply chains for new gas plants are anywhere from 4 to 6 years if you're ready to go. We took a tack at CPS Energy. I have M&A and corporate development on my teams to go buy plants to help protect our community. So we bought about 3,600 megawatts plants. Actually, we bought 4 here in Houston recently. But the grid does need more growth. I am optimistic. The legislature had a lot of foresight and passed a Senate Bill 6 provision, which is requiring these loads to come with generation or be able to move off the grid during times of stress, and I think that's going to be a really helpful tool to help mitigate it, but it is probably the number one thing I think about.
Jesus, what do you think about
Yeah, Bill, I'll tell you, we are very excited at CenterPoint. Just to put things in context, our market, we're about a 22 gigawatt system at our peak. And it took us about 100 years to build our grid that serves the 12 counties in the greater Houston area. And we have line of sight to double, to go from 22 gigs to 40 plus gigs in the next 10 years. And that load growth projection has now been revised where we see it, at least over the next 5 years, shifting based on the demand that we have and the discussions that are taking place. We have Houston is now, the greater Houston area has somewhat been discovered over the past 6 to 8 months, where, and it's just not data centers. For the greater Houston area, it's advanced manufacturing, the efforts that this current administration has had on reshoring is showing up here in Houston. A lot of advanced manufacturing. Life sciences, the mayor talked about Lilly's facility. Lilly is an example for these large industrial life sciences. One of their concerns was, does Houston have the ability to create the market, the jobs, to be able to hire? They have confidence in that. And then it's data centers. So the growth that we're seeing clearly on a megawatt, gigawatt scale is data centers, advanced manufacturing, life sciences. But frankly, our grid has been blessed. We have a significant industrial base. So for us to add large loads, it's not a new thing. We've been doing it for years. The petrochemical refining space. And another dynamic of our market, and it may feel contrary to what you said earlier, but in the 12 counties that we serve, we are seeing growth. In fact, we on a customer base, Bill, we add about 130,000 customers per year. To put that in context, that's a city the size of Waco or Midland every single year. So kind of all of the above, but clearly the big megawatt, gigawatts is in that space. We monitor and have about, in our grid, we import about 40% of the load that we serve. So we have local generation, we import, so we clearly are going to build more import capacity. You'll hear in Texas, there's a new voltage standard being implemented, 765 kV. That's very much now an approved voltage standard. You see a number of projects that are getting built to bring in, think of those as the super highways of electricity to bring that in. So we're excited, we're optimistic, and to answer your point, we're confident that in a deregulated environment that's market-based, that generation is going to get built.
Mike, this is kind of a good transition to you, I think, going into the super highways, kind of your specialty. Can you kind of explain the physics of long line transmission and why they need to be higher voltage? Why do we do all that?
Yeah, so it's a great question, and there was a story in the Houston Chronicle a few days ago about potential pushback to the plan that Jesus mentioned. So ERCOT is planning a series of 765,000 volt projects around the state. And these will go all the way almost to El Paso, largely focusing on serving the Permian through Central Texas, into Houston, up to Dallas, and so on. And the promise of this system is to create an electrical grid where you can meet future loads, okay? Because we can do a couple of things to meet the loads that you talked about. One, we can build more generation. The other is we can manage demand, especially demand spikes, better, and have more flexible loads. And we can build a grid that can move power around the state. And so that's what that's what the plan says that we're going to do. And it's the one thing that was missing in the story, if any of y'all read it, was if we build the grid at the right voltage, we'll have not only lines that are more efficient electrically, in other words, you lose fewer electrons along the way, you'll have a more stable grid because with the higher voltage you get more stability, and you'll have a lot fewer lines. So if you do one structure, one set of lines at 765 kV, they're going to be a little bigger than the 345s that you normally see in Texas, but they can move like 4 times the power, okay? So it's very important that we get this right, because if we don't get it right, we'll be behind the 8 ball in just a couple of years and having to do a whole new series of lines. And right away, as we all know, is precious. But hopefully, this plan will continue to attract support from ERCOT, the PUC, and the legislature, and so on.
For the non-technical people in the room, can you back up just a second?
Yeah.
And explain why the high voltage is important for transmission?
Help me out here. Jesus is the electrical engineer. Help me out.
Yeah, I mean, it's a function of getting its capacity, right? You know, getting that high voltage, so then you can then, you know, step it down into the consumption levels.
Let me give you a simple example. If you have an EV charger and you plug it in at 115, like just your standard wall outlet, it's going to take you like a couple of days to charge your car. If you plug it in at a 230, which is just double the voltage, okay, that's where your dryer plugs in and so on, that same car will charge up in like 5 hours. So it's just a lot more power. Is that a logarithmic relationship?
Higher current, lower current, higher voltage.
Right. Yeah.
Equals the same amount of power.
And less resistance, which means you don't lose as much power.
So Michael, one thing that you and I had lunch a couple of years ago, or a year or so ago, and you were telling me about the possibility of burying high voltage lines. You were talking about some pipeline issues and stuff. Where is that all gone? Are we going to be looking at these things overhead forever, or is there any potential alternative?
It continues to be crazy expensive to bury lines, okay? And Jesus can talk about it with greater authority than me, and so can Elaine, because y'all do that in downtown Houston and downtown San Antonio, but it is, 10 times as expensive.
But I was really thinking more about the cross-country high voltage lines. Just out of the question, or?
Yes. And it's really 2 reasons. I mean, obviously it's cost, but it's also heat removal, right? The higher the voltage, more heat you're producing. When we bury those high voltage, and we do. I mean, from time to time, there are times when we have to bury transmission lines, but we put them in giant concrete pipes of oil to remove the heat. So extremely complex from a civil and electrical engineering perspective, and extremely expensive.
So let's talk for a second about the microphone. It's not working.
I want to move it up a little.
Let me do this. Is that better? How about that?
There we go.
Okay. So let's talk about the local distribution ACEs for a minute, because I think that's where most people have been the most frustrated over the last couple of years with some of these incidents that we've had. One of the things it seems like to me, I read Paul Hobby's report that he did after the hurricane, and the big issue is that we grow trees really well in Houston. And when we originally built out our grid, we put almost all the lines overhead. And so we have this conflict between trees, and people don't like their trees cut down and all these. Can you talk about the challenges and also share with us how much of how much of the utility footprint for CenterPoint is actually underground now? Because I think that's a significant number. But can you explain that challenge a little bit?
So a couple of things for context. I think it may surprise this group that about half of our distribution system is already buried and underground. As you build new communities and new subdivisions, the focus is entirely being able to underground the distribution lines. In fact, in our service territory, we have this concept of a joint trench. And in a joint trench, there's 3 commodities that are in it: electricity, telecommunications, cable, fiber, and then gas. And the 3 entities share the cost structure of that joint trench. So this joint trench concept really drives economies of scale, the ability to drive that pricing point to where it is economical to do, all 3. Where it is extremely expensive is if you have an existing community, rear easements, to be able to take that from an overhead service and bury it, millions to do it on a per mile basis. Now, we are doing some of it. We're doing it for some critical customers, hospitals, and those types of, but that's where the focus is, right? Going forward, I think everything should be buried.
And that's
I think you should also look for...
That's pretty much the case, though, right? Any new development is really buried.
That's correct. Because of the economies of scale of joint trench, and frankly, there's nothing there initially that helps you from a cost structure to do it, as opposed to the complexity of doing it in an existing populated area.
Michael, I know you've done a lot of, you live in an older part of town and you've seen some of these struggles we have. What are the things that we can do about trying to deal with the old part of our grid that's still elevated in Houston, which is, I remember, if you all remember, Peter Brown used to call it litter on a stick, was his comment. It's not only ugly, but it also creates these problems when we have storms and stuff. Is there anything we can do to address that respectively?
Yeah. First off, I think they're beautiful, but we don't have to debate that right now.
Scott Rozelle told me the same thing once upon a time.
So I think as we build, like if we were all king for a day, and I think CenterPoint would probably agree with this, is whenever we do a major street reconstruction, we should just put in the conduit. It's not that expensive, and then we might not use it for a decade, but it's cheap enough that putting it in now is a good investment for the future, and it's a good way to sort of future-proof infrastructure. So that's the main thing that I would think that we ought to do. And we are, I don't know how many miles of roads we rebuild a year. It's not that many, but if you do it for 30 years, you could get it done. I mean, Denmark, for example, in Denmark, you know how many miles, and we're talking distribution lines. We're not talking about the higher voltage transmission lines. But you know how many miles of overhead distribution lines they have in Denmark? Zero.
Zero, yeah.
Okay? It took them 30 years.
Yeah.
But I will even say that it looks actually a little better. But it would take, if we said, all right, let's make this a goal for the city of Houston, by the time we rebuilt all the streets, we could, it's doable.
We should have brought this up when the mayor was still here. I had this interesting experience. We reconstructed North Sheriff and Durham here recently from Loop 610 down to I-10, and I ended up getting involved in that a little bit. I was talking to them, and they just finished a part of it, and I was walking along and all these power lines, poles, telephone power line poles, and I said, why didn't y'all do something? And they actually said the city prohibited it from doing it, which I thought was bizarre. But I agree with you. I think if we got on a program of routinely, anytime we do a major reconstruction of the street, let's go ahead and drop the lines right then, you know. And like you say, even if you don't have the connections now, at least you've got it in the ground for the future. Hey,
Bill,
just how do y'all feel about that?
You know, I call those opportunistic moments, and we're open to those opportunistic moments. I will share that in some examples where we've looked at doing it, Bill, the subject around these pad-mounted transformers now being in front of people's yards became then the next subject where, well, I don't want it in my yard, put it across the street.
Yeah.
Well, I don't want it on my side of the yard. So that will be then the conversation, right, in terms of, do you have the room? Where do the pad mounts go that then serve, because you're taking it from above ground to overhead, so that service drop,
Right.
where does it go?
Yeah.
But open to opportunistic moments, I think that should be part of the conversation.
We're going to take questions here for a second, so my microphone guys, get ready for a minute here. But I want to ask you a question about, so the process that you go through as a local distributor is, you go to the legislature or to the PUC and you file a resiliency plan, and you ask for money to be added to your base that you can then add to your customers' charges for doing various resiliency projects. And y'all just went through this process this last year. Can you just kind of explain how that process works and
Sure.
what the result of this most
Yeah.
recent application was?
So clearly, Hurricane Beryl and the impacts of Beryl was CenterPoint's call to action. We filed and ultimately got approved what is our signature program, our System Resiliency Plan, which is a $3 billion investment in resiliency. It's over a 3-year period, and it is focused on making the grid more resilient to weather events. In the plan, we're going to either install, remove, replace 130,000 poles that, depending on the geography, will withstand weather events such as hurricanes. The objective here is ultimately to stand the punch of a weather event and then recover from it faster than we've done before. Those investments are already bearing fruit. Bill, year over year, from last year, or 24 to 25, we've reduced the number of outages by close to 25%. And when we have an outage, we've reduced the duration of that outage by 25 to 27% or so.
I'll say your website's working a lot better than it used to. I have noticed that. So I have to, we're going to take some questions.
Let me just add a little bit more, because in addition to poles within the System Resiliency Plan, we're also installing automation devices that allows us to segment the system more, that allows us to transfer load between circuits, 1,500 weather stations that allow us to now monitor weather as it's coming in, because then that drives the preparation for a weather event. So our ability to feed the models in terms of the path of that weather event, whether it's a winter event or a summer event, is very important, because it allows us to then say, what's the damage model look like? What's the impact that it's going to have on the system? And then how does that drive us to preposition being key, resources, materials and equipment, so as that weather event moves and that it's safe for us to then deploy our crews, they are ready to get deployed, that we have the right complement of linemen to veg crews, as an example, so that the veg crews are out there cutting trees, removing and giving access to our linemen. And then the restoration process is faster because we have the resources, more targeted. We have the automation that is segmenting, that we can energize a portion of the circuit as we work on another portion of that same circuit. So all of those are part of the system resiliency plan, and I know you will see the results of it.
You've been on the job for 8 months, am I remembering that right?
I've been August 11th, so, but the honeymoon was over week 2, Bill, okay?
I tell you, but I will tell you, I had conversations, I mean, for the last 2 or 3 years, the ones I've had with this gentleman the last, few weeks have made so much more sense than all the ones I had before, so I'm excited about that. I'll tell you my experience with service interruptions. So my wife had been on me for a long time about getting a generator. And so I explained to her that they really don't make any financial sense, that they don't happen enough for what they cost and all that. And so she sat down one day and said, well, let me explain to you that I'm pretty sure that a generator is cheaper than a divorce. So we have a very nice generator at our house now. Okay, let's take some questions here. I see Megan.
Thank you.
Scott.
You ready?
Here.
Ready for one, Bill?
Sure, thank you. I commend you on the fact that you're doing a lot of work on infrastructure. Despite that, the Greater Houston area ranks second worst of the largest metropolitan areas in the United States in terms of frequency duration. The primary measures are events and then minutes. And so, as a consumer, should I, to your point, put in a generator, or should I convert to solar so that I don't have to have interruptions? Or should I play the long game and hope that someday you will catch up?
Well, tell us what you did at HEB.
At one point, our service was so bad. At HEB, when you lose power for more than 4 hours, you throw everything away. And our service was so sporadic that we put large generators in every store south of I-10, now many north of I-10. And then when there's an interruption, we have power, but then we supply energy back to the grid, sell it back to the grid during peak times, and that was the economic model.
Yeah. So you want to take that?
Absolutely, yeah. I appreciate the question, and I won't shy away from it. I am not here to tell you that you will not experience an outage, because you will. It is my job to position the system for resiliency. You will have an outage, but it's in my job to recover as soon as possible. We live in an area where we are prone to weather events. To your point, we have significant vegetation around us. We have very defined easements where we will do a significant amount of vegetation-related work. But there is a lot of risk outside of that easement, where trees that are outside of the easement will fall in, branches will come forward. We've been through drought cycles where we've got dead, dying, and diseased trees. So you will have an outage. My job is, how do I get it restored faster than you've seen it before?
And one of the problems is people don't like them coming in and clearing the trees. We had a situation, I'm on the HOA board, and we have somebody who's, line is in the backyard and they need to go cut it, and he's all mad about it and is not wanting anybody on his property and all that kind of stuff. So it's an interesting dynamic. Who else do we have?
Sorry, Bill, one question or one addition to the answer. So I'm trying to run my thoughts through the Bill King cost of divorce metric versus get a generator versus a battery. I would get a battery. And if you like it, get some solar panels too. But if you get a battery for your house, you can get batteries that'll carry you for 10 hours easily. You turn on the AC, you'll be in great shape. And it's cheaper than a generator.
Okay, good.
I'm curious about, I haven't heard Joel speak much about ERCOT and whether ERCOT is supporting your resiliency plan, or how does it impact us?
So if you couldn't hear that, she was asking a question about ERCOT and where are we at, because obviously there were a lot of problems with the ERCOT model during Uri. So I think probably you're the best to comment on that, Elaine. Can you loan her a microphone there?
Yes, I mean ERCOT has been extremely constructive and supportive of all of the stakeholders, whether that's helping implement changes from the legislature to incent new generation, to reviewing different plans, adopting and bringing forth the high voltage highway that Jesus talked about. I think both our utilities are building that highway. Through new and creative constructs to help us with all the industrial, commercial, and large load growth in the state. So we've seen a very supportive regulatory environment, and we think that that's going to be really helpful for Texas to grow and prosper and to do so in a really reliable manner.
I'll tell you, my sense politically on this is that Uri scared the hell out of everybody in Austin. They were all worried about getting thrown out of office, and I think they got real serious about this. And I'll say one thing, you mentioned the ERCOT website a second ago. The difference in that now from what it used to be, it's amazing the amount of information. In real time, you can see exactly what the loads are, where the fuel sources are. If you haven't looked at that ERCOT site and you're interested in this area, I'd encourage you to take a look at it. It's got an amazing amount of information. I have a question here. This young man.
Hi there, Kevin Sabuni. One, I want to say thank you first for continuing this dialogue. I think when we're looking at certain conversations, whether it's on data centers or other large load users that are coming here in the country, we're seeing a big disconnect between publicity and awareness on the highest level and what it's even trickling down to on the bottom of the spectrum, where it's how it's impacting end users and retail users at the end of the day. And so I think it's important to have discussions like these where we can better connect what's happening at the top as well as at the bottom. I have a two-part question. So first things first, when we're looking at the infrastructure growth that is coming related to a lot of these large load and high power users, what do you think the responsibility is for the public sector and the private sector in investing in this expansion to infrastructure so that we don't get ourselves in situations where the retail users, the consumers, are the ones footing the bill entirely, despite the fact that we're seeing a lot of benefit on the private side and on the businesses themselves? And then my second question is, when it comes to the responsibility of users of these loads, we saw amazing reports coming out of Google in their flexible demand response, and how not only are they a big user of electricity, but the measures and protocols that they're rolling out nationwide to be a responsible participant on the grid so that they can adjust their consumption based on if there are situations like black swan events or other circumstances where the grid needs more support, or if they can actually pull more at the same time. So those are my
Elaine, you
two
want to
questions.
take that? That's
Sure. The first question you asked was really about fairness. As we think about these large loads, I joked about it a little at PowerGen. I said there's kind of the 3 F's. There's the physics, there's forecasting, the physics, and fairness. Physics is not an F, by the way. But we think about all those. But on the fairness component, it's really twofold, right? But I think first up, knowing that Texas is growing, we all need to invest in the transmission system. We got to move this power around, and that's going to be apportioned in a fair manner, like it has been, since we formed an integrated market. For those of us who are retailers or serving customers, it's about rate setting. It's about making sure that we're making sure all of the costs associated with growth and load goes to the drivers of growth and load. And there's rulemaking at the state to relook at the transmission allocation, but that's the whole piece. It's about fairness. I'm actually optimistic, very optimistic, that as we grow the use of our integrated system as a state and certainly as a company, you're able to spread your fixed costs, because this is about, like, we manage a big electrical highway, right? And it's a fixed cost, right? And so as we can grow the use of that highway, we can actually help drive down or mute the cost increases on retail customers with all that additional sales. So I'm optimistic there. Relative to flexibility, absolutely. I have to we gave a shout out to HEB, great partners, and George Prestis is amazing. And all of our commercial and industrial customers that help us been doing this a while, where they've actually been partners in load shift. We saw it during Uri. We have a number of large load users in our service territory. That Monday morning, a lot of people moved out of the way. And so I mentioned Senate Bill 6, but we do have, as I mentioned, the legislature was really had a lot of foresight and put in place provisions to require these large loads to come with resources. And I think we're seeing a willingness of all the major hyperscalers to bring their own generation and to be great partners to harmonize the grid during tight conditions.
Anybody else got anything on that?
Just growth is good and it has been good for the CenterPoint transmission and distribution system. I'll give you a fact. In our market, CenterPoint is considered a transmission and distribution service provider, TDSP. Our portion of the bill that you receive from your retail energy provider has a component on it for that charge, the poles and wires. Our component of that bill has remained largely flat over the past 10 years. And the reason is because of the growth that I talked about earlier, where we've seen this, maybe not at the core of Harris County, but in what we call the outer ring counties, where some of those counties have seen 30 to 50% growth over the past 10 years.
Yeah. Now the demographics are, all the growth for the last 10 years has been in the suburbs in this country. And that's not just here. I think this is 23 or 24 data. 92% of the population growth took place in cities that have less than 200,000 population. So you've got the rural areas are losing population, the urban cores are losing population, and the suburban rings around the big cities are the ones that are growing. Although I will caution you that even that is getting ready to turn over, because it's just a function of we're not producing enough babies at the end of the day. Any place in the world, the only place that there will be any population growth between now and the end of the century of any consequence is going to be Equatorial Africa. When you start talking to global demographers about what the world's population is going to be, the only thing they ever talk about is Equatorial Africa, because that's the only place where the birth rates are still way above replacement rate. Like I said earlier, 75% of the world is at or below the replacement rate today. That means that in a generation or two, their population is going to start falling. In 25% of the world today, the populations are already declining. This is happening a lot faster. And I talk to people doing infrastructure, I talk to people in government, I talk to school. I give this speech about this topic probably twice a week right now. And I'm just amazed how little recognition there is of what this is going to look like a decade or two down the road. We're so accustomed to this, so built into our intellectual, assumptions about everything. And it's a function of, unless somebody thinks that women are going to start having a lot more babies, and occasionally I'll be at one of these speeches and somebody will say to me, typically a man, they'll say, well, don't you think women are going to start having more? And so I just look around all the ladies in the room and I say, okay, anybody here think that women are going to start having a lot more kids? And I've yet to have any woman raise their hand and say that was the case. And let me say, and I don't, there's a sort of the pro-natalist people out there these days that are trying to come up with all these ways to get women to start having more kids. There's a downside to that, and I'll give you a very clear example of it. The team that came up with the CRISPR technology for gene editing, 100% woman team. Now, would you rather have them not discover that and instead go and have 4 or 5 kids each? I don't think so. There's a tremendous increase in human intellectual capital because ladies like this are doing this as opposed to staying at home and raising 4 or 5 kids. And so I don't think we're going back ever. This is just the new reality that exists. And as countries become more advanced, they get further down in this. So I can just tell you, Jesus, where you may have added a bunch of customers, the next 20 years it won't be nearly as many customers you've added in the last 20 years. Back here, okay. Hey, Mike, how you doing?
Good morning, Bill. Very stimulating discussion. I wanted to follow up on the fairness issue and a current trend on electric vehicles. I'm glad to hear you endorse fairness. I remember the days when every man for himself said the elephant as he danced with the chickens. And being a chicken, I'm very sensitive to that. One of the little guys. So I hope you're right. We played with politics on the grid with respect to who could put a battery on the grid. I hope that's been resolved. The point I want to get to is, or my question, with respect to electric vehicles. We used to look down the road and say, my gosh, how can we afford to power the transportation sector? It's going to double the load on the grid. We're now talking quadrupling. But in the issue of growth, how much of that 130 that kilowatt growth that you talk about, not just new customers, but the growth in demand on the Houston grid, is from electric vehicles that we're charging at home? And how much are we capable of supporting?
Mike, you want
I'm not sure about the exact numbers, but it's increasingly a material part of the growth to the grid. Now, the advantage, particularly in Texas, that we have is, well, you can pick the time of day when you charge your car, and most retail plans, and you can find options where you can pick your time of day or price by the time of day, and the technology is getting better and better, so you just plug it in and forget about it, and it'll charge when power is cheapest and most available. So in terms of generation and stresses on the grid, EVs should be additive because you're moving more kilowatt hours through the same infrastructure. That would be my sort of quick answer on that.
Yeah, I think it's important to understand that, absent a catastrophic failure like Uri, what we're really talking about is managing power during the day because of the air conditioning demand stuff. So you've got this big peak in the afternoon, early evening, and then at night it goes to very, very low demand. So look, we're over time here, so would you all help thank this incredible panel with that for coming? Thank y'all so much. Very nice to meet you. Thank you. Yeah.